This is example 11.5 from Discovering Design of Chemistry. Your stomach produces hydrochloric acid, HCl, that is used in the digestion of food. Sometimes, however, it overproduces HCl. Antacid tablets are meant to neutralize the excess HCl that comes from the overproduction. If the stomach overproduces 84 milliliters of 0.10 molarity HCl, how many grams of MgOH2, an active ingredient in some antacids, would be necessary to neutralize it? So this is a lot of words. Let's break it down. All right, so we're talking about this acid, HCl, and we're talking about neutralizing the excess HCl, and we're going to use this to neutralize it. So those are the pieces that we're starting with. Let's go ahead and make an equation, since we're kind of putting things together and figuring out what their relationships are. Starting with an equation can help us see the relationships between those and count. Okay, so let's also put information that we have from the problem. So we know that the stomach overproduced this much of HCl, and that's the molarity. So let's go ahead and list that. So we have 84 milliliters, which is 0.084 liters, and then 0.10 molarity. This one's nice, but not the one we'll use. If we're using molarity, remember we have the molarity equals the moles per liter. So we need things in moles and liters and then molarity. So that's why I converted the milliliters to liters. All right, and then what we want to know is grams. Super. So we know in our previous problems we went from grams to grams by putting grams to moles, move it to the other moles, and then move it to the other grams. To do that, we need to be able to put these numbers in moles, and then we need to be able to make sure that we know how many moles we have of each of these to relate them to each other. So we have to finish our chemical equation. So we're going to put the H with the OH in the form of H2O, and then we're going to put the MgCl together. Now, before we just jump to the end, I could open up my periodic table. What I'm going to actually do right now is I know this H is a plus, that means the Cl is a minus. If I checked the periodic table, I could see that it's in column 7, so it would still be a minus. And then because of this 2 right here, I know that OH is minus, and there are 2 of them, so there's 2 minuses. Oh, that looks like an equal sign. Let's not do it that way. So let me put -1 and -1. So that means this must be a 2 plus. So I have a 2 plus here. So when I put together this MgCl, it's going to need a 2 right here. I could also use the periodic table to figure that out, but I can see it just from working with the numbers that I have. All right, and let's make sure it balances real quick. We may need to add some coefficients out front. So I have over here, what color do I want to use? Let's stick with purple. All right, I have 1H here and 1H here. That means I have H's in 2 places, so I'm not going to deal with the H's. I'm going to go ahead and erase my 84 milliliters since I've already converted it to liters. That way I have a little bit more room to work. And I'm going to put my chart over here where I keep track of all my different elements. All right, so H's we're not dealing with. Cl, I have 2 on the right and 1 on the left, so let's go ahead and put a 2 over here. So now I have 2 on both sides. Mg has 1 on each side right now. O has 2 on the left and 1 on the right. So let's go ahead and put a 2 here, and now I have 2 on the right. And let's see if that fixed my hydrogens. So I have 4 here, and then I have on this side 2 plus 2, which makes 4. So I have 4 and 4. So this is my balanced equation. So 2HCl plus MgOH2 yields 2H2O plus MgCl2. It's very important that you get this equation right, because if you don't get it right, the number of moles you're comparing of one thing to another won't be right. You can't just write the things and not balance it. All right, let's get rid of my chart. Now that it's balanced, we're good. We don't need that. Okay. So I've got the molarity of this one and the liters of this one, which means I can use my formula for molarity and I can figure out how many moles I have. Because moles is what I want, I'm going to rearrange this to say moles equals the molarity times the volume, so times the liters. So moles equals 0.084 liters times 0.10 moles per liter. I'm probably going to have to erase my work because it's going to get in the way of the other thing in a minute. My liters cancel, leave me with moles, and I can work that out. So 0.084 times 0.1, and it's actually 0.10, so I get two significant digits. So all I have is, well, that's all I have anyway, so 0.0084. So 0.0084, and that's how many moles of this I have. Now, if I want to know the grams of my, give me a second, let me erase this up. If I want to know the grams of the MgOH2, what I need to do is I need to figure out how many moles I have and then just simply convert it into grams. So I have 2 moles of HCl for every 1 mole of MgOH2, which means the moles here needs to be converted to the number of moles here. So 0.0084, and that's the moles of HCl, will be multiplied by moles HCl on the bottom, moles, that thing that I don't want to rewrite on the top. And so 1 and 2, the moles here and here cancel, and then I can put that in my calculator. So this one will have 0.0042 moles of MgOH2. You probably could also easily see, hey, I'm going from 2 to 1. That means I need to take this number and divide it by 2. Give me half. You can also always write your conversion relationship and use that to figure it out to make sure you get it right. All right, so now I'm down to the step where I'm still trying to figure out how many grams I need of this, and I have the number of moles. So we can use our conversion relationship to convert this from moles to grams. So we can pull out the periodic table, but I'm just going to go ahead and tell you how many grams per mole. So we have for MgOH2, it's 58.33 grams per mole. So let's take the number of moles we have, which is 0.0042 moles, and then we're going to multiply that by grams and then moles on the bottom. So 58.33, the 1, our moles cancel. Of course, this looks like it's lined up under this other thing, but this is MgOH2. And then let's pull out our calculator. So 0.0042 times 58.33, and we only get 2 significant digits because of the 0.0042. Only the 4 and 2 are significant figures, so we're only going to keep 2, so 0.24. So that equals 0.24 grams, and that's what we were going for, is how many grams of MgOH2. So 0.24 grams. All right, so for this one, just like the previous ones, we had to figure out our equation. That was step 1. Step 2 is to write down everything you know. We knew the liters and we knew the molarity of the first one, and then what do we want to figure out? The grams of the second one. And then we thought about the path. When we're relating two things, we can go from one to the other. This one doesn't involve any gas laws like last equation, so that's nice. We're just kind of reverting back to things we did in the previous chapters before that, where we took figure out moles of one, convert it to moles of another, and in this case we converted it back to grams. But if we had known the molarity of something, let's pretend that MgOH2 had been in some aqueous solution and we knew the molarity of that, we could have used the same equation to find the liters of that if they had asked for it in liters. But since they asked for it in grams, we just did the same thing we've been doing for a couple chapters, where we converted moles back to grams using that molar mass. All right, so that's the end of that problem.